The freaks! Welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host, meteorologist DT from Weather Risk, your captain of chaos, your colonel of confusion, your commander of catastrophe. Let's talk about This Week in Weather as it's December 28th, 11 o'clock at night. I thought I was going to do it on Friday morning, but decided to do it tonight. So we have a pattern change, which is still underway. I know it's the fact that it's not going to be snowing tomorrow morning or this weekend at your house. It means that it's not a pattern change for some of you, but that's just, well, stupid to have that mentality because we'll get into that in a little bit. The real issue here, we'll talk about Canada and the need to refill the cold air supply. That's a problem. We'll talk about January 4th, what should be a significant snowstorm for the mid-Atlantic, or at least portion of the mid-Atlantic and southern New England, the lack of cold air. The January 7th threat, which may be a bit more serious since the atmosphere will be colder and longer term. So let's get right to it. Here is, of course, the website. I'm sure you've already seen it. If you haven't already, you should, especially if you're doing snow removal. I know we haven't got any snow yet here in the east of significance, but I do not believe that's going to stay that way for long. I think, I still think quite bullish about the second half of this winter, or 2/3 of this winter, I should say, still ahead of us. This is, of course, the two Twitter pages. This here is the grain page, and this here is the snowstorm page. And if you're watching this video, you're probably interested in the snowstorm page. This actually over here is the threads page, I should say. This is the threads, and this is the grain page. All right, so let's start out here taking a look at this condition here. And what I'm going to do is I'm going to call up my marker so I can constantly use this here on a regular basis. And then I'm going to change the color to black. And there we go, and then I'll just copy it all the time. Okay, so we can do this. So this here's the upper air pattern. You can see as of this Thursday, there's the upper low. And we had the initial low bringing at the rain here. But this still upper low is hanging back. It may bring some snow showers Friday night or Saturday to portions of the central Appalachians, West Virginia, Western Maryland, but not really a big deal, as you can see here. So that's probably not going to be a big deal. Now this here is the sea surface temperature map of December 28th. You see the area in black here? You notice the water temperatures here are warming up nicely on the west coast of North America. That may be the beginning of a warm phase of the PDO, which would be great for later on this winter. And of course you can see the raging El Nino here in the central and eastern Pacific Ocean. All right, let's take a look at our teleconnections here. We have two on the Pacific side, the EPO, the Eastern Pacific Oscillation, the Alaskan Ridge or Trough, and the PNA, which is the West Coast Ridge or Trough. And on the Atlantic side, we have two here, the Arctic Oscillation, which could be positive or negative, and the NAO, which is the Greenland block, more or less. Could be the Iceland block or the Quebec, northern Quebec, whatever, but the NAO also has positive and negative phases. And there are several combinations, as you can see here. So we can cross-index these combinations to see get an understanding of what the pattern looks like. So on the Atlantic side, we can see here, this is the NAO, and as right now you see it's neutral. Then what happens is as we go into the new year, it trends negative all the way through January 15th. Now it's not sharply negative, but it's fairly negative. And here is the Arctic Oscillation. Now this, as you can see, it's positive here. Now it's gone negative as of December 28th, and then the forecast has this really negative, at times moderately to strongly negative, all the way through January 15th. If we look at the extended projections here, we can see again some certain, now this is the European, which goes out to 46 days, and this is the Arctic Oscillation. And of course the greens and the darker the greens and the blues, that represents very negative values, and the yellows and the oranges represent positive values. So as you can see throughout most of this time frame, the Arctic Oscillation generally stays positive. There's a little break maybe in some of the models here, runs around January 20th, but it's only that cluster. Most of it keeps the Arctic Oscillation negative throughout most of January into February, as you can see. Now, the GFS also has a 35-day projection for our Arctic Oscillation, and it's even more negative. Look at this, very negative, very few positives here at all the way through the month of January. All right, let's take a look at the NAO, the Greenland block. And again, here's the European 45-day. It's pretty negative. Then you have this in-between period here towards the end of the month. It's kind of neutral in some areas, and then it starts going negative again. The NAO and the GFS ensemble is what I'm trying to say, is much more negative, as you can see here. So out to 35 days. All right, let's take a look at the Pacific side. Remember, this is now the Pacific side here. We're looking at the EPO and the PNA. So let's take a look at that. And here's the latest projections. Now here, we're all over the place. Okay, we're positive. Now we're about neutral, and then the projections go either side of the positive and negative values here. They're all over the place in Alaska, and that's part of the problem with the pattern, because obviously you want to keep a negative EPO if you want to get cold into the eastern U.S. And right now we're not really there. We're kind of neutral. And the P&A, which as you can see is positive, look at the black dots, we're positive right now. That stays positive, then it kind of goes negative here a little bit, or close to neutral around January 10th. So, and that's going to be when we have another major impulse is going to move in from the Pacific, and that's why the P&A is going to turn temporarily negative. Okay. If we look at the long-term projections, here is the EPO, the Eastern Pacific Oscillation, the Alaskan Ridge or Trough. When it's negative, you get a cross-polar flow. And as you can see, the EPO is back and forth here. There's no real strong signal one way or the other for January through February. Just not seeing much of it. And then the GFS ensemble, a little more negative towards the end of January, and also back and forth here for the next 2 weeks. And then you go late 10 days of January, it's much more negative. On the P&A pattern, the West Coast Ridge, well, we're positive now. Then we go negative where that trough arrives on the Eastern Pacific here. And then we go positive end of January into February on the European. And the GFS ensemble, same thing. Strongly positive, then kind of neutral, and then positive towards the end of the month again. So that's a good sign. All right, let's take a look at the maps and see what's going on here. So this map here is for Saturday afternoon. And you can see there's a trough that's leaving us now. There's a piece of energy we're coming down right here. Short wave number 1, short wave number 2, short wave number 3. So let's take a look at this. This is the one for January 2nd. This is the one for January 4th. And this is the one for January 7th. Now we do have a ridge here bringing down some cold air. So that trough amplifies. But you see the problem is the axis is on this trough here. Let me blow it up for you. You can see it a little more here. Here you go. This trough is positively tilted, so the low forms here and goes out to sea. See what happens? It's positively tilted. Now this is an upper low. This is really gonna hit California pretty hard on Monday with a lot of rain and mountain snows. And we're getting some cold air trying to get in, but the problem is Canada is still very, very warm. We're not getting the cross-polar flow. So even though you're getting a northerly flow here, it only brings in a little bit of cold air. Okay. This is the January 4th threat. Here we go. So the map on the upper left, let me blow this up a little bit, and then I'll bring it forward. There you go. So, oops, they didn't come forward for some reason. Bring front. There we go. Ah, I see what I have to do. So here we go. This is the short wave, the southern stream short wave, and there's this number. This is number 3. This is number 2. That was number 1. So you see here, there's a short wave. There's a northern piece coming down like this. Okay, they're going to merge here. This is neutrally tilted along the Mississippi Valley, which is not bad. That's pretty much what you want. All right. We've got some ridging in Western Canada, but again, you're not getting direct flow. I mean, getting some flow of cold air, but Canada is so bloody mild, and that's really a problem. So this is January 4th. We're getting some cold air coming southward. Now, the bottom right map, let me shrink this one a little bit so you can blow it up. There we go. Now, you can see the short wave. It moves off the southeast coast. You see what happens? This upper low kicks this feature east. See, this upper low comes into California very strong and it kicks this one east. Right? And again, look at the flow of Canada. This is kind of Pacific air, a little bit of cold air here, but mostly Pacific air. This is not really Arctic air here. And let me show you how that affects things. Now, the GFS, the operational GFS, it completely loses this system. All right? The operator has had it. It has not showed the system at all. This is the same problem the GFS has had for years with southeast U.S. lows, keeping them flat and off the coast in the extended model. So this is now day 7. And again, we're not trying to find the rain snow line here at 7 days out. Really, folks, come on. Let's be realistic, okay? We're just trying to see what the model is showing, get an idea of what our options are, what might be happening. That's all we're trying to do here. And the point here is that GFS has nothing. The one in the upper left, this is the 12Z GFS from Thursday. The one on the bottom right is 18Z. It's got nothing. It doesn't show up at all. But here's the ensemble. Huge differences. This is the 18Z. I can present the 12Z if you want, but again, that's more slides than I need to make. But this is the 12Z showing the same sort of thing. Look at all the low pressure areas here, right? Okay? This is valid early morning Thursday, January 4th, and now it moves parallel the coast, hitting New England and the eastern mid-Atlantic. This, if we have enough cold air, this is a classic East Coast snowstorm track. Classic. The problem is the lack of cold air. That really is the problem. So the GFS ensemble has this. Okay, so this is telling you the operational GFS is crap. It's just nonsense. Stop using the GFS. Stop posting a 300-hour GFS, the 294. It's nonsense. Look at the ensemble. Okay, if the operational model matches the ensemble, then you have something. But when it's like this, stop. Just don't do it. You look like an idiot. It doesn't have any value. Really, it doesn't. Okay. Now, this is the GFS ensemble in terms of the precipitation. Again, very different from this. Okay. Now, in this problem here, we can use the zero line. Let me call it my marker. Okay. This blue line here, this is the zero line 850. Let me blow this up a little bit so you can see it. Okay. This blue line is the zero line 850. This is the normal rain snow line. You see the low here? Now this is way too warm. In this air mass, you have to use like -2 or -3. So the rain snow line is actually behind this line. So this is rain for DC and Baltimore and Philly and New York probably. Snow in maybe Roanoke a little bit, Shenandoah Valley, West Virginia, Western Maryland, Western Pennsylvania. Okay, this is as of the morning of January 4th. And again, the real problem is just the lack of cold air. Now this one, we blow up a little bit. Bring it forward. Okay, the low's off the coast. Now New England's getting hit. New York City has snow. Much of eastern Pennsylvania, New England's getting snow. Long Island's got rain. Cape Cod maybe rain. Boston has snow. A bunch of New England does. It's gone over to snow and maybe in Charlottesville and in D.C. and in Baltimore as the low intensifies. This is a classic early winter. Now this is January, so maybe, but again, if we had a normal winter, this would be a significant snowstorm, and the rain snow line would be much further south. This is, okay. South Jersey's rain, Philly maybe snow and rain, or snow, and the suburbs all snow. Same thing with Baltimore and D.C. Okay, Charlottesville, and then north of Charlottesville, the northern Shenandoah Valley, west. This is snow. Okay, so we're starting to warn our clients already. January 4th has got possibilities. We'll see what happens. Okay. This is the European operational model. Now, the European has a big storm. Again, look at the difference. Operational GFS, nothing. Operational European, boom, big storm. Of course, you can see the cold front, all the snow, again, because of lack of cold air, even though you have two cold highs here, one in Oklahoma, one in Lake Superior, it's not enough cold air. So all the snow is restricted to the mountains of West Virginia, Southwest Virginia, Western Maryland, western half of Pennsylvania, and interior New York State. And then and here we go. The European moves up the coast, rain all the way into New York City, Baltimore, D.C., Philly, all of Virginia. You can see that. Okay? Now, the ensemble is different. The ensemble here is having a bit more of a problem. The ensemble doesn't have this system. January 4th has got the low here and here. So it's got it a little further up the coast, but the problem is the temperatures. Now, if we look at the ensemble mean on the European, again, here it's a little colder. And this is the zero line. You see the blue line right here? This is the zero line 850. If this was a normal winter, this would be the rain snow line, but it's not. So you have to use like -2 or -3. This is -5, so somewhere between this area. So, it's rain in Raleigh and obviously most of North Carolina, probably eastern half Virginia, Richmond, Tappahannock, into the Delmarva, but north of Charlottesville up to D.C. could be snow. And indeed, if we blow this up, now this one here, this is for Thursday. This is January 4th, 7 a.m. The one I'm blowing up here, let's blow this one up. Okay, this is 1 o'clock on Thursday. And there's the rain snow line. It's actually moved towards Richmond. Now this is a little colder. So right up in here, Northern Virginia, could be D.C., Baltimore, Washington, New York, Philly. There could be some snow in this area here. All right? And if we go further, if you look at the temperatures, this is Thursday morning, January 4th. Richmond's 38. That's rain. Okay, we know that. Charlottesville, 33. That could be snow. D.C., 35, 36, but the suburbs, 33, 34, 32. Same thing in Philly and New York, and so on and so forth. Okay, Shenandoah Valley looks pretty good for snow. because it must have, what most of interior western Maryland and Pennsylvania, typical early season event, okay, without a lot of cold air. And as we look at the ensemble solution, as we go into the evening of January 4th, here's the European ensemble. It is colder still. Look at the zero line. It has gotten much further south, okay. So could this end as snow in Richmond? Yeah, Central Eastern, yeah, maybe. But you definitely have snow in New York City now. You're -5, 850. Same thing in Boston, Connecticut. The Delmarva, sure. Now, this doesn't look like a big snow, but it's definitely got possibilities. So again, yes, I'm still thinking January 4th is a threat. Even though the operational GFS looks like a piece of shit. It's just an awful looking model. Okay. And the European, it's probably too warm. So, it's always something, boys and girls, isn't it? It's always something. All right, let's take a look at Canada. Where is all the darn cold air? This is the temperatures as of going to be valid December 28th. This is valid for Friday evening. All right. So this line here, let me pull it up. Okay, you see the zero line here? These are surface temperatures. See that? Surface temperatures. This is zero line. 0 degrees Fahrenheit is way, way up here. Look at this. This is very mild air for northern Canada. Now, Greenland's pretty cold. Way up in here it's cold. But this is nothing. Okay? Look where it is down on the North Dakota-Canada border. It's like 10, 15 degrees, It's nothing. 20. It's, this is unbelievable. So, and if we look at the 850 temperatures, okay, as of today, this actually as of Wednesday, the 27th, I should say, so yesterday. This is just pitiful. These are 850 temperatures, 1 mile above the ground. It's too warm for snow in north central Canada. Can you believe that? Okay, not Manitoba, north central Canada, up by the Great Bear and Great Slave Lakes. It's too warm for snow at the 850 levels. Are you kidding me? No, I'm not kidding you. That's how warm it is in Canada. All right, now look what happens. Here comes the buildup. Okay, and then one on the upper left is January 2nd. Oops, let me put that in there so you can see it. January 2nd. And then January 7th. So we can see the blue really coming up here. And so by the time we get to January 7th, look at the explosion of cold air. Compare that to this. January 7th, December 27th. 10 days later. See the difference? So this is the pattern change. Here is the pattern change. It's getting cold in Canada. Now, should this have happened back in November and early December? Yes. Okay? So we're behind schedule because of the mild pattern of the El Nino. Okay? But it is changing. Okay? So in order to get snowstorms in the Midwest or the East Coast, you have to have Canada cold. If Canada is not cold, it doesn't make a difference what the low pressure area does or doesn't do. It doesn't make a difference which model is correct. If South Central Canada is not cold, you're not going to get your big winter storms in the Midwest or the East Coast. It's just that simple. Really, it is. All right, this is January 7th. Let's talk about this threat. So we talked earlier on January 4th threat here that this shortwave in California, coming into California, this one right here, is the next system. That's January 7th, right? Okay, so that now we look at this in more detail, and what happens, here we go. So there's a short wave. You can see it very nicely in the Baja in northern Mexico, right? Now here, what's different on this one is, we're assuming this map is correct, of course, as always. Bring it front. Okay, you see this huge upper low? Right here? This is bringing down cold air now. See the direct flow? This is direct cold air coming southward. This giant upper low. So if that's true, the atmosphere is going to be colder on the Mid-Atlantic and New England for snow from this short wave. If that's true. We don't know if it's true. It's 210 hours out. It might be complete BS. But assuming that's true. Now, then we go to January 7th, and you can see the short wave is very strong here in Texas, Louisiana. Another piece of energy coming down, and you have an upper low in southeastern Canada. Okay, so that's and now we're getting blocking in Greenland, building into the Arctic region. So this is finally going to take into place. There's your negative NAO. There's your 50-50 low. There's your southern shortwave. Not bad. Not a bad pattern. Not great, but not bad. And then if you look at the day 10 European, there's the low in Texas. Okay, nice high to the north. And another big one coming down from south central Canada, finally. Now, the ensemble has something. The European ensemble has a January 7th or 8th. Not a huge system, but it's got something there. It's 10 days out. And there's the 18Z GFS. Now, the 12Z GFS, I didn't post it, had a big storm almost at low over Atlanta and had the range of Virginia already. Here, the 18Z takes it out to sea. Just 6 hours later, a completely different solution. All right. And if we look at the GFS ensemble, it is very aggressive. It's very aggressive. It's a serious threat, January 7th. Look at this. So we have all these members, the low pressure areas here. This is January 6th, and there it is the night of the 6th into the 7th. A classic Miller A, another coastal storm. We've had a lot of these coastal storms so far this winter, and if you think about it, we have this event on January 4th, right? Then we have the one on January 7th. We already had one a couple of weeks ago. So we're having a lot of big coastal storms from the southern jet stream. And that's, it's working out very nicely. So this is, again, if we had the cold air, this would be a big deal. Now, the one for January 6th and 7th, the atmosphere does appear to be colder for looking at right now. Now, it can change, but it does look colder. Okay, good. So there's the GFS ensemble. And as you can see, if we look at the actual temperatures, the GFS ensemble, here's the temperatures for Sunday morning at 1 a.m. from the 18Z in the upper left and the 12Z. And they're very similar. There's the rain snow line, 32 degrees just north of Richmond, 32 degrees in Danville, okay, up towards New York City, Baltimore. Classic rain, line right along I-95. It's what this is, really. You think about it. Okay, so that's pretty consistent. Well, we don't know if 2 degrees can make a big difference, obviously, but we can't tell at this point where this is going to be. Just you can't tell. Okay, it just gives you an idea. If we look at the ensemble, now the ensemble and the algorithms on the GFS ensemble, you can see it's much colder. It has snow into western North Carolina on January 6th. See that? Okay, the rain snow line is much further south, as you can see. And then if we go here and blow this one up, this is January 7th. There's the low again. It looks really nice. All right, so so it's a pretty good looking system. I gotta tell you, it's a pretty good looking system. It's got potential. Now the model is producing some snow. Even look at that in western North Carolina, if you can believe that. Hickory, Greensboro, Richmond. Not a big deal. It's a long way off. It's just a start. It's just a start. Okay. Like I said, this appears to be a colder system. So there we go. Longer term, the MJO. We'll look at that. Now, what I'm talking about, the point here is, you have to look at the right MJO models. For example, this is the one from the Australians. Now the Australians, let me call it my marker here. See, it's got it here. The phase here, the red is the next 5 days, the blue is the next 10 days, and the purple is the next 11 to 15 days. So it goes from phase 3 to phase 4 and 5, and then phase 6. These are fairly mild patterns for the winter in the eastern U.S. But let me shrink this one down here. This is the Australian when you take out the model bias, when you correct it. And here you can see it turns it into the neutral circle. It does not go into phase 3, 4, or 5. See the difference? So you have to keep that in mind. This is the European versus the GFS. As you can see, the European takes it into the neutral circle. Once it gets to phase 3, it does not go to 4 or 5 or 6. It goes back into the neutral circle. This would mean that the pattern would remain unchanged. It would not turn mild. The GFS is different. It brings into phase 4, 5, and 6. So we have to keep that in mind. And the reason why that's important, if you go to phase 3, that's a really good East Coast winter storm pattern, as you can see. Keeps a negative anomaly right over the eastern United States. It's fairly cold and potentially stormy. Now, for last slide, and then I'll stop for the night. It's been going on for a while here. This is the GFS extended, and this is the European extended. And the point here is, Canada is now much, much colder. Okay, well, and you can see the negative anomaly on the GFS is in the Midwest. On the European, it's a little further to the west, the Rockies. But both models show tremendous blocking here. Very strong negative NAO, both of them. All right, the trough is pretty broad. There's no East Coast ridge, so that's okay. And you're getting flow straight out of northwest Canada running into the country. Now, is this an Arctic outbreak? Probably not. I don't see that. No. Is it colder? Cold enough for winter storms? Yes, it is. Is this the type of pattern where low pressure systems in the Midwest and the East Coast can draw in the cold air from southern Canada? Yes, it is. So this is a much colder overall regime. This is January 12th and January 14th. So, January 4th to look at, January 7th to look at, maybe something on January 9th as well. I didn't get to that because that's far out there. And the pattern looks pretty good. So there we go. Now, I did not get into whether or not the polar vortex is going to split or the sudden stratospheric warming. I'll do it another time. This has gone on for 25 minutes already, and 38 or 39 pages or slides. So that's enough already. Let's call it a night. This is meteorologist DT from Weather Risk. I'll see you over on the Twitter page and over on the Weather Risk Snowstorm Twitter page, or the website, and on the Facebook page.